Hi and welcome. So in this video, I'm going to show you some methods we use for visualizing distributions. And it's very important to understand what the distributions of data are before you start running any machine learning models or doing any other statistical modeling, because it can really drive what decisions you make in terms of models you select or how you work with them or whether you need to do some transformations. So let's have a look at some practical cases here. So on my screen, I have some code. We're going to make bar plots. This is from the auto prices data. And we're going to just look at a few columns that are categorical variables. Make, body style, number of cylinders. So those are categorical variables. And so what does my code do here? So first off, I loop over the columns in that list. And for each column, I'm going to, with matplotlib, I'm going to first off specify a plot area, a figure basically. And I'm using 6 by 6 as my dimension. So that's how big my figure will be. Approximately 6 by 6 inches, but it's very approximate, by the way. And then the other thing I need to do is define an axis. So the axis is, since I'm only making a single plot in each case, there's just one axis. So I just can use this on the figure object that I created. I use this GCA method to define an axis. Now, what I want to do is make a bar plot here. And I'm using the pandas plotting method. And I'm using pandas because it's fairly abstracted. So counts.plot.bar. So counts are my counts. So you see I have to compute a pandas series. A series, recall, is just one vector of values or one column of values, unlike a data frame that has multiple columns. And from that column, I'm going to apply the value counts. So I just select from the data frame that column. I apply the value counts method, and I get counts. So then I can apply this plot.bar method to my counts on that axis that I've specified. I'm going to make my bar plots blue, just for no particular good reason, just because I like blue. And then I'm going to give my plot a title, and I'm going to give it an X label and a Y label, and I use plot.show here to make sure the plot displays. So let me run that for you, and we'll talk about the result. So first off, here's our first plot. And you see this pandas plotting actually does a really nice job with very little overhead. I did specify the axis labels and the title. And you can see it automatically rotated the text so I don't have overlapping text. And I can right away see that Toyotas are the most frequent cars in that data set. Nissan's the next, and Mercury is the least. And notice that this was ordered. It's an ordered bar chart. And that's very important when you're trying to interpret the data or if you're trying to present it to your colleagues. Always use an ordered bar chart because it's much easier to see where the differences are. And they can be in ascending or descending order. It doesn't really matter, but it should be ordered. And we can see a similar thing for body style. We see we have sedans as the most frequent, then hatchbacks, wagons, hardtops, and finally convertibles are the least. And you can see there's not much difference between the count of hardtops and convertibles, but because it's an ordered bar plot, we can tell that difference. And similarly by number of cylinders. In fact, there's exactly one car with 12 and one car with 3, so there is no difference there. All right, so that's for categorical variables. That's our main graphical tool is a bar chart. And you could do this for a combined or interaction term between two categorical variables as well. That would work just as well. So let's talk about histograms. So for numeric variables, we need to use histograms. So a histogram looks superficially like a bar chart, but it's different because it has a bin. So imagine that the numeric values are binned within equal width bins. And you see, I can say how many bins I want here. That's one of my arguments. And I'm again going to use a pandas plotting method. So I'm going to take whatever that column name is. You see, I'm going to do 4 different numeric columns, 3 characteristics of the car and the price, which is the thing we're most interested in modeling. And we'll just make a histogram on that axis with however many bins we specified. In this case, we're just going to go for the default of 10 bins. And again, I put labels. And it's really important to use labels for your axes and your plots because otherwise your audience has no idea what this plot is you're showing them. So right away we can see histogram of curb weight. And what can we learn from this? Well, it's not exactly a bell-shaped curve, but it's not too terribly asymmetric. It's a little bit what we call right skewed. You see that the tail seems to be more to the right. The bulk of the distribution or the mode seems to be to the left. Engine size. Engine size is definitely strongly right skewed. You see most cars seem to have fairly small engines. Only a few cars have really large engines. And so we get this strong right skew, this long tail. And that's an important thing to know when you're building a machine learning model, that you're going to have this skew. And we will probably wind up doing some transformation of that feature. Miles per gallon, city miles per gallon, which is a measure of fuel efficiency. Again, it's mostly symmetric, except it's got a few outliers. So again, that's something to note. There's these outliers that these certain cars that get exceptionally high fuel efficiency, whereas most cars are somewhere in the middle of this range. And price. And price, again, there's a strong right skew, but there's also 2 modes. You see there's a mode here. Most cars are pretty inexpensive. And then somewhere, I presume these are the luxury cars, there's another mode for the luxury cars. So it kind of indicates there's something going on here with 2 different classes of cars. Okay, so histograms are just one tool we have for looking at the distributions of numeric data. We also have kernel density estimate plots. And again, I'm going to use Seaborn package here. And we got SNS.setStyle. So I'm going to create a grid. And on that grid, I'm going to, with however many bins, 10 bins, I'm going to create a histogram. So hist equals hist, right? And I'm going to include something called the rug. I'll show you what the rug is. And then otherwise, again, axis labels as before. So you can see the kernel density estimate plots, and they look a little different from histogram. You get it's not that the information is different between here, which is curb weight, and here. You just get a different view. Your mind picks it up more. You definitely see the tail. You see there's almost another hump. And the rug, this is the rug. So the rug shows us the frequency of occurrence or the density of occurrence of the cases, which is what the density plot is. And also notice that it's normalized. You see it's a estimate of the probability density. So notice these are no longer counts on the vertical axis. It's some normalized number, and the whole area under this entire curve adds to 1 if you integrate it. And you can see with the engine size, the right skew is really definite. You can see mostly symmetric with the miles per gallon or fuel efficiency, except for these 3, and now you can see with the rug, there's 3 very fuel efficient cars, and the rest are all sort of, almost looks uniformly distributed. Probably isn't. And price, likewise, again, we see this cluster of high-priced cars, which are presumably some luxury cars, and the rug, and you can see it's so dense down here around the mode that you can't even tell how many ticks there are. So one other trick you can do is you can combine those, and so we're going to go the same function I just showed you. You see I had hist equals hist, and the default is false. So that's why we just got the kernel density estimate plots. But I kind of like showing them both together. And you can see different things on the same view. You see some detail from the histogram and from the rug, and you see this nice smoothed representation from the kernel density estimate plot. And especially when you get to something like price of the car, which has a lot of structure, your eye takes in all these different aspects, and you really get a good feel for the distribution. So those are some methods we use for looking at distribution. So for categorical variables, bar charts are our tool, and remember, always use ordered bar charts. And for numeric variables, we looked at histograms, kernel density estimate plots, and the combination of the two. So we get slightly different views from each of those approaches to the numeric variables.